Hello, in this video I will explain the quantum numbers of electrons. Each electron in an atom has a unique set of quantum numbers according to the Pauli exclusion principle. No two electrons can share the same combination of four quantum numbers. The quantum numbers are important because they can be used to determine the electron configuration of an atom and the probable location of electrons. They are also used to understand other characteristics of atoms, such as ionization energy and the atomic radius. The first quantum number is the principal quantum number n. This number describes the energy level of an electron inside an atom. As you can see from the picture, n takes the values from 1 to the last possible energy level, and it cannot be 0. As you can see, the first circle represents the first energy level, where n is 1. The second circle represents the second energy level, where n is 2, and so on. The larger the number n is, the farther the electron is from the nucleus, the larger the size of the orbital, and the larger the atom is. The second quantum number is the angular momentum quantum number L. This number describes the shape of the sublevel within an energy level. As you can see from the picture, we have four different sublevels. The first one is S, where L equals to 0. The second one is P, where L equals to 1. The third one is D, where L equals to 2. And the fourth one is F, where L equals to 3. The values that L take are 0, 1, 2, till n minus 1. For example, when n equals 1, L equals 0. When n equals 3, for example, L equals to 0, 1, 2. That means that we have three sublevels in the third principal quantum number, which are S, P, and D. The third quantum number is the magnetic quantum number m sub L. This number determines the number of orbitals and their orientation within a sublevel. Its value depends on the orbital quantum number L, which means when L equals 1, m sub L equals to minus 1, 0, 1. When L equals to 2, m sub L equals to minus 2, minus 1, 0, 1, 2. So we can say that m sub L takes the negative values of L, 0, and the positive values of L. The last quantum number is the spin quantum number m sub S. Unlike n, L, and m sub L, this quantum number doesn't depend on another quantum number. It designates the direction of the electron spin and may have a spin of positive half, represented by an upward arrow, or a minus half, represented by a downward arrow. Which means when m sub S is positive, the electron has an upward spin. When m sub S is negative, the electron has a downward spin. So let's have this example. Find the four quantum numbers in 3D8. Well, we know that this number represents n, so n equals to 3. And in the D sublevel, L is always 2. And we know that m sub L always take the positive and the negative values of L. So, -2, -1, 0, 1, 2. Then we start the electrons configuration with upward arrows first. 1, 2, 3, 4, 5. Then downward arrows. 6, 7, 8. And we stop here because we have only 8 electrons. So, we notice that the last electron is in the 0 sublevel. So, the value of M sub L equals to 0. For M sub S, we know that M sub S is either positive or negative 1/2. In this situation, the last electron has a downward spin, so the value of M sub S is -1/2. If the electron has an upward spin, the value of M sub S would be a positive 1/2. So the values of the 4 quantum numbers are 3 for N, 2 for L, 0 for M sub L, and -1/2 for M sub S. I really hope that this video was helpful for you. Thank you for listening.